In lesson 3-7, we'll be working with functions and graphs. In example 1, we have the function y equals 3x plus 1. Our domain items, that are input for x, are -1, 0, 1, and 2. So when we rewrite the equation with -1, substituting for x, we get 3 times -1 plus 1. 3 times -1 is -3, plus 1 is -2. For x equals 0, 3 times 0 plus 1. 3 times 0 is 0, plus 1 is a +1. For x equals 1, 3 times 1 plus 1 is 4. For x equals 2, 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. You see that each of my output or range values for y are increasing by 3, -2 to 1, that's an increase in 3, 1 to 4 is an increase in 3, and 4 to 7 is an increase in 3. That increase in 3 is coming from our coefficient value. This table can also give us our ordered pairs for graphing. The solution for the function at x equals -1 is -2. That gives us our ordered pairs -1, -2, where x is first and y is second. Our second solution, when x is 0, y is 1. Our third solution, when x is 1, y is 4. And when x is 2, y is 7. We'll be using these points and tables like this one later in our lesson to then graph our functions. In example 2, we see that we'll have the graph here. Okay, our function is y equals x minus 2. I'm going to rewrite that function on top of my xy table. Y equals x minus 2. And as I see here, I have a blank table. It means I can choose any input values or x values that I want. I'm going to choose values that not only fit on my graph. I see that I go 1, 2, 3, 4, 5 is my largest value for x in my graph. I'm going to also use values that are easy for me to work with. So I'm going to choose to use 0, 1, 2, and 3. When x is 0, 0 minus 2 is -2. When x is 1, 1 minus 2 is -1. When x is 2, 2 minus 2 is 0. When x is 3, 3 minus 2 is 1. Now, I can use those points as my ordered pairs to graph my function. So when x is 0, I start at the origin, and x tells me to go left or right. Since it says 0, I won't go anywhere. And y tells me to go up or down, and it's -2, so I'm going to go down 2. 1, -1. That tells me to go right 1, down 1. So I'm going to start at the origin, right 1, down 1. There's my second point. My third point, right 2, and I'll stay right on the axis line. So right 2, and I'll stay right there. Fourth point that I have, I'm going to go right 3 and up 1. So I'm going to go right 1, 2, 3, and up 1. Okay, I notice that this function has created a straight line, so I'm going to use my straight line tool to draw a straight line between these points. I'm going to add arrows at the end of this line to show that it will continue forever in both directions. And the fact that this line is straight, another word for straight is linear. Functions that we're going to be dealing with are linear functions, which mean that they're going to result in straight lines. So that will be a check for ourselves when we're graphing our points. If we do not get a straight line, then we made a mistake with our ordered pairs while graphing, and we need to check that again, because all the equations that we're working with should result in straight lines. Example number 3, y equals 2x minus 1. In this example, I don't have a table over here, but you are going to need to create a table for yourself in each one of these problems. So we need to create an XY table. And we need to choose what points we would like to use. Again, I want to choose points that are going to fit on my graph. And so for this case, again, 0, 1, 2, and 3 will work nicely. I'll write my function over here so I can see it a little bit easier with my table. Y equals 2x minus 1. When I put 0 into the equation for x, 2 times 0 is 0, minus 1 gives me a negative 1. When I put 1 in for x, 2 times 1 is 2, 2 times 1 is 2, minus 1 gives me 1. When I put 2 in for x, 2 times 2 is 4, minus 1 is 3. And when I put 3 in for x, 2 times 3 is 6, minus 1 gives me 5. Again, I'll use these points knowing that this should be a linear or straight line. And I'll go left or right, none. I'll be right on the axis, and I'll go down 1. So I'll stay right here on the axis, down 1. And I need to go right 1, up 1. Right 1, up 1. Right 2, up 3. Right 2, up 3. Right 3, up 5. Right 1, 2, 3, up 1, 2, 3, 4, 5. I see that my points would line up in a straight line, so I'm going to use my line tool to draw a straight line between these points. And I'll add my arrows to show that this line would continue, because my function would continue if I added more values. And I do see that this is a straight line. If I compare this function with the previous one, I notice that it is increasing at a faster rate. I can contribute that to my coefficient of x. 2 is greater than just the 1x that we had before, so that's causing my graph to increase at a faster rate. Example number 4. Again, I need an XY table. And I'll bring my function over here so I can see it with my XY table. And I can choose any values as long as they'll fit on my graph. So 0, 1, 2, and 3 will again work for me very well. If I put 0 into the function, I'm going to get 0 out. So I know one of my points is going to be at my origin, 0, 0. If I put 1 in for x, it becomes negative 1. So when x is 1, y is negative 1. When x is 2, y is negative 2. When x is 3, y is negative 3. So I can go ahead and graph these points. I know I have 1 point right at the origin, 0, 0. Then I'm going to go right 1, down 1. Right 2, down 2. So I'm going to go right 2, down 2. And I'm going to go right 3, down 3. Right 1, 2, 3, down 1, 2, 3. Now I'll use my line tool as I see that this creates a straight line between these points. I'll add the arrows to show that this function will continue on. And I would like to notice a difference between this function and the other two functions. This function, our first function that we graphed, was increasing from left to right. The second graph we said was increasing from left to right at a faster pace because we were multiplying by 2. In example number 4, I'd like to notice that this graph is decreasing from left to right, and I'm going to notice that this one had a negative x, which is causing us to decrease. In example number 5, we're going to work with a decimal. So again, I need to start with a table for my x's and my y's, where x is my domain and y is my range. Domain is my input, range is my output. So when I copy my formula over here, 0.5 times x plus 1, I'm going to choose values for x that are going to work nicely for this equation. Since it's easier to take a half of an even number, I'd like to use even numbers. I'll start with 0 because that one will work well for us. And then 2, 4, and 6. 0 times 0.5 is 0, plus 1 is 1. 2 times 0.5, that's half of 2, is 1. 1 plus 1 is 2. 4 times 0.5 is half of 4, which is 2. 2 plus 1 is 3. And 6 times 0.5 is 3. 3 plus 1 is 4. So I can graph these points. 0, I'm not going to move anywhere, and I'm going to go up 1. Right 2, up 2. Right 4, 1, 2, 3, 4. Up 1, 2, 3. And my last point, I notice I get off of the graph a little bit. So I can assume that when I create a straight line through my points, that my last point would end up right about here at 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Again, this line will continue forever. And I'd like to notice a difference between this one and the last one. Again, this one was decreasing from left to right because of our negative x. And this one is positive 0.5x, so again, it is increasing.